All right, hey guys. This video is for test crosses. So we want to make sure we're able to answer questions and determine parent genotypes using a test cross. So a test cross is basically backwards of a normal Punnett square problem, where in a test cross we have the Punnett square or the offspring's genotypes, or we can figure out those genotypes, and from there we can kind of use reasoning to figure out what the parent's genotypes are. Okay, so we're going to use this one as our example. So in our test cross, we have parents, or it's asking what parents would result in half of the offspring having a green pods and half of the offspring having yellow pods. And it's important to know green is dominant over yellow. Okay, so green being dominant, that can be, doesn't give us an allele, so let's do G for green. So for this, green can either be one of two genotypes. It can be homozygous dominant or it can be heterozygous. Right? Either one would still express a green pod. For yellow, being at the recessive trait, it can only be little g, little g. So the fact that half are green, they have to be homozygous dominant again or heterozygous. But the fact that half are yellow, and we can just go ahead and take this and put it in our Punnett square, right? Half of the Punnett square has to be yellow pods, right? So we know, based off of this, again, half of them are yellow, that we have to have a little g here and a little g here, as well as a little g here, right? Because otherwise, if we put a dominant allele on the tops or on the sides, we get heterozygous, and then we get green pea pods. Next, we know that half are green, so we have to have at least one uppercase G. We can also take these G's, lowercase g's, and put them in. And then we can kind of see, okay, so then this has to be heterozygous. Right, so then from there we have our parents. Right, we have one heterozygous pea plant that's green, and we have one homozygous recessive pea plant that is yellow. So this would be our answer. Right? So test crosses, you find the offspring's genotypes first and work backwards. Have a good day.